questions you would wanted to hear the answer to what?
If someone that answers like within 8 through 13 and like the answer to 17.
Sure. Yeah. Okay. Let me see. So I'll just go through one or two from 8 through 17. So the directions are use the graph of the related function. Now, it's really, really important that you understand that when we are graphing, we're using the word the related function. Okay, that's a really important distinction to make because today we're going to be solving the quadratics in a different manner, and people they kind of get these two things confused. So I want to make sure that you understand that when we're talking about the related function, so in this particular one, if I have x squared equals 4 for number 8, what am I graphing? What is the related function?
Y equals x squared minus 4.
Okay, what am I graphing? If it says use the graph for this one.
That's number 7.
That's number 8, right? Where am I? I'm gonna move my. Right there. Okay. What am I graphing? It said use the graph of the related function. What does that mean? Stephen?
Use the graph y equals negative x squared and y equals negative 9.
I did
X
Am I on the right page?
You're looking at 7.
He's looking at 7.
Oh.
I'm looking at 8, right?
Oops.
Sorry. Kayla?
y equals x squared minus 4 is what I did, and I got that answer.
Okay. You need to I'd like everybody to take out their calculator.
I did y equals
Y equals x squared, y equals 4.
Yeah,
That's, and that's, I can't, I need a marker.
Yeah, the last one. I just tried to get it done. So.
So please graph, let's look at this. These are those, okay, everybody ready? Okay, so what are we asking? What is the question for this? What do we want to know at this point? Kristen?
For which value of x
Okay,
squared?
this is asking what are the x values that will give you what? 4. Okay? And so we graph y equals x squared. And we can also graph y equals 4. And when we, first of all, where's the vertex going to be on this? 0, 0, right? We know that it's going to be at 0, 0. And so we're looking for, and if this is, what are the values that of y? This is, y equals, and this is my y value. So what are the x values that will give me that? That's what I'm looking for. So if I graph y equals x squared into my calculator, which is what you should have done, that is the related function. That's going to be different than if I graphed y equals x squared minus 4. Sorry, right. Okay, why is that different?
Because the vertex is down 4.
Yeah, look at that. Isn't that a totally different function? Okay, so you really need to be careful with that. Okay, because we're going to be doing something today and you'll see why that could be confusing. Brett?
Couldn't you just, like, I know it's kind of different, but if you know that x squared equals 4, then you know that the square root of 4 is 2, or
Yeah.
you just do 2
Okay. You're actually jumping ahead into the other lesson because this was graph it.
Right.
Okay, so you were doing it algebraically, and we're going to be doing.
No, I graphed it last night, but I was just kind of thinking that you could.
That's a good thought because that's another way of solving it. Okay, you're going to learn. Okay, we're going to be learning 3 different ways to solve quadratics. One of them is by graphing. You're going to be able to punch it into your calculator and graph it. The beauty of technology. Okay? Or in my day, we had graph paper and you plotted all the points. Think about how much easier it is with a graphing calculator than having to do, multiple graphs. So there are other ways to solve it. Let me ask you this. Is graphing always accurate? Why? I'm sorry, I didn't hear you. What? No, I mean, like I could find places, but I'm talking about what kind of numbers?
There's decimals.
Fractions.
What is that decimal that goes on and on and on?
Irrational numbers?
Okay, so if I have an irrational number, will my calculator give me a precise answer? No. But could we, for instance, if we're talking about a number that's an irrational number, the answer is the square root of 2. If we can compute that, is that a more accurate answer than what our graphing calculator can? So, I mean, a graphing calculator is great depending on what the job is. If you need something that's exact, you're doing multiple computations, sometimes you want the actual number and not the rounded answer. Okay? All right. So, Kayla, so do you understand? When we're talking about the related function, we're looking for, we would use this. And in this particular one, what was this? This is problem number 11. I would plug that in. I would use equals f of x, so I could plug that in. I might graph 8 as well, or hit my trace button, and there's no real solution. Okay, so is there anybody else have any questions on those?
Can you do number 17?
Yes, no problem. I just want to make sure that we were good with understanding when we're graphing, you're using the related function. Okay? Number 16. It said rewrite each in standard form. So in standard form, what am I doing?
0.
I'm writing it equal to 0.
So when you have one like 15, then do you just leave it, or do you have to add in the completing the square thing?
You would multiply it out. What is x plus 4 squared?
X squared plus 16.
X squared plus 8x plus 16?
Yeah.
Right? I would just,
That's your answer?
it says write
Oh,
each in
okay.
standard form. Standard form, remember, we talked about this yesterday, would be when it's 0 is equal to ax squared plus bx plus c.
So how would you do like 16 then? I'm not sure why this is escaping me.
16, because by definition, what did we say it would be in standard form? It would be equal to 0.
Subtract 7.
So I would subtract 7,
But then you don't
Oh,
have.
and I would have I would have 0 equals what? 5x squared plus 3x minus 14?
Okay, yeah, that makes sense. Maybe just reorganize it. Okay.
Okay. All right, anybody else have any questions on those? Then let's look at number 17. Now, I was just talking to Laura a second ago about the word problems. These are the presents on the SAT. Because all they're asking you to do is plug in information. You don't have to do a whole lot of thinking on these. You just have to, they're intimidating for some. And I don't know exactly, actually I have to download, I got the scores of your class that took the SATs, the PSATs, and then as the chairman I can go and look at the questions. And I don't have your individual scores, but I have as a group what problems people got wrong. So I will look them over and then maybe come and look at some of the word problems, and we can do some of the word problems together. You might find that helpful. But anyway, so, and the other thing that you need to remember is mathematics is the language of what?
Numbers.
The kinetic energy of an object. Do I teach kinetic energy? No. Mathematics is the language of science. Okay? And that's why it's math and science usually are aligned together. Because science teachers are always telling us they don't know how to do blah, 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 blah. Okay? So we have a responsibility to make sure that when you go to science, that you are successful. Okay? And I wish we did more together because it would be kind of cool if you do. It's kind of hard sometimes to teach it together because it would mean that we would have to stop and learn other things, but anyway. So the kinetic energy in King's Arthur Court. The kinetic energy, they're just giving you a definition here, plain and simple. The kinetic energy of an object measures its energy due to motion. Okay, in the metric system, the basic unit of kinetic energy is a joule. You guys in chemistry? You're talking about joules now, okay?
Yeah, we did it a long time ago.
Okay, but that's what you've done. So when the velocity of an object, v, and now they're giving you the initials. When the velocity of an object, v, is measured in meters per second, and its mass, little m, is measured in kilograms, its kinetic energy, Ke, in joules, is this formula. So they're telling you the formula. They're not asking you to derive the formula or anything else. So now they're making it a little bit fun. They gave you a little picture. Did you guys like the nights when you were a kid? Didn't you like that? If you ever get to the Metropolitan Museum of Art, New York City, they have a phenomenal collection of knights in armor. The real stuff. It's like, holy cow. Anyway, so Sir Lancelot and Sir Galahad are going to a tournament, and in the joust, Sir Lancelot will ride Camelot Slough, I don't know, and Sir Galahad will ride Water Biscuit. Okay, their masses are shown. So the weight in armor. So are the horses wearing armor too?
Yes.
Yes. The horses are wearing armor too. I mean, gosh, can you imagine somebody's coming at you with these lances? You didn't have any armor? All right. This is about reading. Okay? You guys are smart cookies. You gotta read carefully. Okay?
Just, what were the answers?
All right. For each, I'll give you the answers in a second. For each combination of horse and rider, combination means what? Horse, rider.
the only one who did it.
Combination. Find the velocity necessary to generate a kinetic energy of 10,000 joules. This is what? Plug and chug.
I plugged in chugged.
Right? And if you plugged and chugged,
Hey, if you wanted to run, if you really wanted to run.
okay, plugged and chugged, what did I do? What did they give me? They told me it was going to be 10,000 joules, and they gave me, how did I get 1,000?
130.
Yeah, I had to figure out. I added. Oh, look at that. 1,300 and 870 was 1,000, and it was velocity squared. And so I want to know what v squared is. Divided both sides by 500. 100 divided by 5 is 20. You need to find the square root. It's going to be what?
Decimal.
About 4 something, because 4 times 4 is 16, 5 times 5 is 25. So it was about 4.47.
Which one's that?
That was number, what?
17.
17.